Welcome back. If you're just tuning in now, you missed a lot. We're here with Polly Pipestein, and there's one question left standing between her and $1 million. Polly, are you ready?
Yes, let's do it.
Alright, your $1 million question is... What is the best polymer in the world? Is it A, polyethylene, B, polypropylene, C, polyvinyl chloride, or D, polystyrene?
Oh boy, I don't know. This is a hard one.
Now remember, you still have your phone and friend lifeline that you can use.
Golly, I think I might have to use that one. I might have to call my friend, Shane, and who is a polymer expert.
Alright, we'll get him on the line in a second.
Hello?
Hi Shane, you are speaking with Regis Philbin, and I am here with your friend Polly on the game show Who Wants to Be a Millionaire. Now Polly is on the $1 million question, and she wants your help to answer it, so here she is.
Hey, Shane.
Hi.
Okay, so the question is, what is the best polymer in the world? Is it A, polyethylene, B, polypropylene, C, polyvinyl chloride, or D, polystyrene?
Okay, I'll be right on it. Okay, so Polly wants to know what the best polymer in the world is. Obviously, it's polyvinyl chloride. But just to be sure, let me show you and explain why. I mean, $1 million is hanging in the balance. Okay, first, let's understand the basics of PVC. Polyvinyl chloride has a tetrahedral molecular geometry. That means that it has a 109.5 degree bond angle. Now, there are two types of PVC. There's flexible PVC and rough PVC. Rough PVC is used in construction and plumbing for things such as piping. Surprisingly, credit cards and IDs, such as your driver's license, are rough PVC, not flexible PVC. PVC has a melting point between 100 and 260 degrees Celsius. That's almost 500 degrees Fahrenheit. That's really hot compared to other plastics. The heat stability of raw PVC is very poor, so the addition of a heat stabilizer during the process is necessary in order to ensure the product's properties. PVC starts to decompose when the temperature reaches 140 degrees Celsius, with melting temperature starting around 160 degrees Celsius. The linear expansion coefficient of rigid PVC is small and has good flame retardancy, hence the reason why PVC has such a wide difference in the range of the melting point. You are all probably wondering how PVC is made, so let's take a look. First, you need a Cl2 molecule, which can be found anything that has Cl2. In order to get it down to just Cl, or a chlorine ion, you need to heat it. Now, that chlorine has one lone electron, and it needs to bond in order to have 8 electrons. So then you take the VCM, which is vinyl chloride monomer, and take one of the double bonds between the two carbons and split it. Put one bond, one electron on either side of the carbon. This allows the chlorine ion to bond in with the carbon ion to have 8 electrons. This allows other VCM monomers to bond continuously, so on and so forth, linking the chains together. This is the basis of the PVC polymerization process. When PVC is first produced, it is made as a white powder that kind of looks like baking soda. The presence of chlorine in the molecule makes PVC particularly versatile because it makes it compatible with a wide range of other materials. The chlorine content also helps to make PVC flame retardant. Now the question is, how does this powder become the hard material and the flame-resistant material that is in this pipe? Well, the answer is plasticizers. Plasticizers are additives, most commonly phthalate ester. Now, if you take that and add it to the powder, bam, you get PVC. Phthalates, which are incorporated into plastics as plasticizers, comprise 70% of the U.S. plasticizer market. Phthalates are by design not covalently bonded to the polymer, which makes them highly susceptible to leaching. Some monomers exist in the form of reactive gaseous chemical substances, and some of these may cause health hazards when in direct contact with humans. In these cases, they are manufactured and processed under strict control for health, safety, and environmental protection. On the other hand, polymers such as PVC, which are manufactured from monomers through polymerization, are solid and chemically stable substances, therefore do not affect human health. One problem associated with all plastics is the devastating effects that it has on the environment. However, PVC is one of the most recycled plastics in the world. According to Vinyl Plus, over 445,000 tons of PVC was recycled in 2013. PVC is commonly used by plumbers for piping. Now that is because of its water resistibility and its durability. Unlike metal pipes, water will not corrode the plastic pipes. Other things such as dirt also will not corrode these pipes. You all probably have heard of PVC before even seeing this. This is because of the vast applications that it has. PVC is used in, well, obviously pipes, but it also is used in some of the coating for electrical cables. It's also used in signs, window and door frames, healthcare, and surprisingly, people have found a way to make furniture and even clothing out of PVC. You're probably wondering, how can PVC be used in healthcare? I'm not talking about insurance, but the containers and the tubes that are used in hospitals for such things as blood and urine collection. Tubing is also used for blood taking and blood giving sets, as well as catheters and heart-lung bypass sets. PVC is also water resistant. Because of this water resistance, PVC is used to make things like shower curtains and also raincoats. Okay, now that we've examined all the evidence that polyvinyl chloride is the best polymer in the world, let's tell Polly.
The final answer is C, polyvinyl chloride.
Okay, thanks Shane. I'm going to have to trust Shane on this one and say PVC. My final answer is C, polyvinyl chloride.
And the answer is C, PVC. Congratulations, Polly! You just won $1 million.
Your money.